Welcome to a lesson with Dr. Powell. In this video, we're going to take a look at f of x equals x to the fifth, and we're going to compute the derivative of this function using the a strategy in a limit. So the way we're going to do that is we're going to do a synthetic division. There's more ways of doing this than that, but we'll do that. So here we have x to the fifth, and our other point is a to the fifth, rise over run. A to the fifth minus x to the fifth over a minus x, and we're taking a limit as a approaches x. All right, so again, in this limit, we're going to think about a as being the variable, x as being a constant. So in the last video with x to the fourth, look at that video to see the explanation for what we're about to do. Okay, so the top we can think about as a polynomial in powers of a with different coefficients. So it's like 1 times a to the fifth, 0 times a to the fourth, 0 times a cubed, 0 times a squared, 0 times a, and then the constant term, because x is a constant in here, in this limit is negative x to the fifth. And so we're rewriting this fraction in a form where we don't have to have division by a minus x. We do that by actually computing out the division and doing it here. So we have that. Next, we can think, okay, we're dividing by 1 times a plus negative x. Negative x is the constant. The opposite sign of that would be x. And so then we just proceed. We have a 1, x, bring the x down, x squared. Bring the x squared down, multiply x cubed. Down, multiply x to the fourth. Add x to the fourth is x to the fifth. Notice you add, you're going to get 0. Now with powers of a, this is constant. That's a to the first. That's a squared. That's a cubed. That's a to the fourth. Then what we're doing is we're taking a limit. So this part right here is actually equal to our original fraction, at least not in domain, but algebraically they're equivalent. So that it works to throw in x for a. So every a, we can replace it with x, and it will be the limit of this. The limits will coincide because this expression is algebraically equivalent to that one. Domain is changed, so now we can throw in a is equal to x. And in doing so, notice we get each one of these terms are going to be x to the fourth. We're going to have an x to the fourth plus 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 x to the fourth. 1, 2, 3, 4, 5. I'm going to get 5 of them. 5x to the fourth. We just computed the derivative using the a strategy and the limit definition of a derivative. Thanks for watching.